Let's look at another example. This is repeated linear factors. Write the partial fraction decomposition of x to the fourth plus 2x cubed plus 6x squared plus 20x plus 6 over the x cubed plus 2x squared plus x. So notice that it is improper, meaning the numerator, the degree of the numerator is larger than the denominator, so we need to divide using long division. So x cubed plus 2x squared plus x, and then x to the fourth plus 2x cubed plus 6x squared plus 20x plus 6, and then we'll divide. So x to the fourth over x cubed is x, goes over the x piece here, and so this is x to the fourth plus 2x cubed plus x squared, and then plus 0, and then you subtract. So change all the signs to opposite. So we notice we get 5x squared plus 20x plus 6. And then so that is our remainder. So how we write this, like we did before, so x plus the 5x squared plus 20x plus 6 over the divisor of x cubed plus 2x squared plus x. So now let's factor the denominator. So this factors out an x, so this is x squared plus 2x plus 1. And then this factors to x plus 1 and x plus 1, so it's x plus 1 squared. So that will be our denominator here. So let's rewrite it. Let me write it at the bottom actually, give us some space. So x plus 5x squared plus 20x plus 6 over x times x plus 1 squared. So now we're going to include a partial fraction for each power of the denominator. So meaning we have x plus 1 to the square, we're going to need to write one with x plus 1 and another one with the x plus 1 squared, because we have to include all possibilities of the denominator. And so we could have either of these possibilities. So let's try this out. We're only going to work with this side here. Okay, so we can just ignore the x and we'll add it back later on. So we're going to write the partial fraction decomposition of the rational expression here. And let's write it. So we write the constant a over, we have a single x, plus b over the x plus 1, then c over the x plus 1 squared. Okay, so again, you're including a partial fraction. Include a partial fraction for each power of the denominator. Okay, so you'll have several examples for homework to practice with this on. So for example, if this was an x squared, okay, just for example, then you would have a to the x plus b to the x squared, and then c over x plus 1 plus d over x plus 1 squared. Okay, so just as an FYI, that's what would happen. Okay, so there's no square. Let's go back to doing this problem. So now let's do the partial fraction decomposition. Let's solve. So we're going to multiply by the LCD. The LCD is x times x plus 1 squared. So it's this here. So now on this left side, it'll just be 5x squared plus 20x plus 6 equals, now we have a times x plus 1 squared plus b times x times an x plus 1 plus c times x. So for here, I can just leave this as it is. I don't need to simplify this. And so we can see that we can plug in certain numbers. What are some good numbers we can plug in to solve? So we know that we can plug in x equals -1, because that'll make this 0. And then we can also plug in x equals 0, because that'll cancel out the b and the c. So let's try that out. Let's first start with x equals -1. So 5 times -1 squared plus 20 times -1 plus 6 equals a. -1 plus 1 is going to be 0, plus b, -1 over here would make that 0, plus c times -1. So that's nice. That'll help us solve for c, or negative c. So this becomes 5 minus 20 plus 6 equals negative c. So negative 20 plus 6, that is going to be negative 9 equals negative c, or 9 equals c. Now let's try x equals 0. So that's a little faster. So 0 plus 6. I'm just plugging it in here. And then equals a times 1 squared plus b is b times 0 plus c times 0. So we get 6 equals a. So now we're out of numbers to choose. So in this case, what we could do is we can substitute x equals 1. So let me write it. Substitute a equals 6 and c equals 9 into the equation. And let's just choose some x value, any x value. So let's just choose a positive 1. So, you could choose any x value again, just choose one, that's nice. But that's how you would solve for, we only need to solve for b. Okay, so that'll help us solve for b. So let's substitute. So 5 times 1 squared plus 20 times 1 plus 6 equals a times, well, we know what a is, so let me back that up. 6 times 1 plus 1 squared plus b, we don't know what b is, b times 1 plus 1 plus c times 1. Ooh, we know what c is. C is 9. Okay, so substituting everything that we know. So now this becomes 5 plus 20 plus 6 equals, 1 plus 1 is 2, 2 squared is 4, 6 times 4 is 24, plus, this is 2, so this is 2b plus 9. So now this left side becomes 31 equals 24 plus 9 is 33 plus 2b. Subtract 33. We get negative 2 equals 2b, or b equals negative 1. So there's our last value. So now we can write our partial fraction decomposition. And so remember that we have to include the polynomial. So we divide it, so we need to include this x. And so this is going to be x plus, our a value is 6, so 6 over x plus our b, which is negative 1 over x plus 1, plus c is 9 over x plus 1 squared. Okay, and you could rewrite this again where you could make the negative down here and this a positive, but either one is okay. Now you could check the answer. You know how to do that. You would add these all together, and then you should get your answer back. So go ahead and try this example here. Write the partial fraction decomposition of x to the 4th plus x cubed plus x plus 4 over x cubed plus x squared. All right, if you tried this out, you needed to divide using long division. And so it divides x times, and so we'd rewrite it. You have it here. And then what's left is the remainder is x plus 4 over the x cubed plus x squared. You factor that to x squared times x plus 1. So then you have the x plus 4 over x squared times x plus 1. Then you write the partial fraction decomposition with the constants on top. So you have a over x plus b over x squared plus c over x plus 1. Then you multiply by the LCD, which is this here, the x squared times x plus 1. So you get your basic equation, which is x plus 4 equals a times x plus 1 plus b times x plus 1 plus c times x squared. You try negative 1, you define c is 3, you try 0, and b is 4. Then you try any number you want, plugging in b and c. So I tried 1. So b is 4, c is 3, x is 1. I plugged it in, and so I found that a is negative 3. And then I plugged in the partial fraction, I wrote my partial fraction decomposition. So x plus a is negative 3 over x plus 4 over x squared plus 3 over the x plus 1.